Another Riley update. Been doing lots of little bits and pieces. The weather was good enough to take the frame outside. I did a bit more on the woodworking. I still have a little tiny bit I still need to sand. I had to add in some little extra blocks just to fill up a hole, because I want the timber all around the back of the seat to be smooth so that the seat fits in nicely. So I'm going to do that after I've done this, probably, since it stopped raining. I've been playing with a few other things. I've had some parts arrive. I tapped the little drain plug for the water pump. I'm not going to bother with a little brass tap. I just put a bolt in there that's less likely to leak. And I also ordered and received an MGB speedo cable, but it turns out to be wrong for a couple of reasons. One, the fitting on this end, which is the end that goes to the gauges, is too small, and it also turns out that the square drive is too big. It doesn't actually fit the back of the gauge. So I was looking around at all my boxes of bits. This is the MG one that I had that actually worked, and the problem is when you look these things up online, you basically order them by year, and the MG was made for a long time, so was it 62 to 80, something like that. So there were quite a few variations, and you end up buying the cable based on what year it is, what gauges it's got, whether it was an overdrive gearbox or not. There's all sorts of things, but they don't actually say what the ends are, so it's a bit hit and miss. So I had a look at the ones I had, and I realized I had this other cable which is about the right length, but it had the wrong ends on it. It was also actually a little bit too short. I think maybe one of these ends of the square drive had broken off a little bit. So I had a look at what I had, and I discovered it's actually pretty easy to take these things apart. The ends, this is an original one, they're just sort of crimped on, and you can easily pull those off. I just sort of hold the end of the cable or end of the connector gently in the vise, and then just yank on the end of the cable, and they'll come apart pretty easily. So I ended up pulling apart the one I bought and made my own cable, effectively. Now these are crimped on. I imagine there's a special tool for doing that, but what I ended up using was this. Now this is a crimping tool, it is a proper crimping tool, but it's actually for doing electrical connections. And it's a little hydraulic thing. It comes with these detachable jaws, and these, you get a sort of set of them. They're all different sizes, and these are actually used for big metal ring terminals, so doing things like battery connections. But it turns out you can use this to crimp the ends back on these speedometer cables. So what I did here is I made up a cable with the right sort of fitting for the gearbox end. I believe this is I think it's 3/4 26 TPI. It's really hard to actually know what these threads are, and they definitely vary. But this now has the correct threads and the correct thread on the gauge end to actually fit my little Smith's 4000 reverse drive. It also fits other gauges like these, which I can't remember what these are from. One set of these came from a friend, and another set came from someone who kindly sent me some because they weren't using them. So I've been playing with different setups. I've basically matched this cable end. It turns out that speedos and tachometers don't necessarily have the same sort of drive, or rather thread on the end. So this is a speedometer, and it's got a different size one again. So what I have now is a cable that will fit with my gauge, and I think that is correct for Smith's type tachometers. In order to actually drive it, because this is a square drive, I went to the local model shop, which is close to where I work, and got some, I don't think it's going to focus on it, square hollow brass tubing, and that's the right size to fit onto there. And to drive the to pick up the drive from the end of the camshaft, which is slotted, I made up this little piece. So this is a little piece of high tensile steel. I machined that and milled the slot on the end, and that engages into the back of the camshaft. I drilled it and I soldered in a little piece of that square brass tubing, and that's what provides the drive to the cable. And the way this works is this fits into the brass fitting on the back of the block, and it's threaded, so that screws on. In order to take up wear, so the brass bush, the cam is a brass bush, so this will be steel running in brass. I think that whole area is full of oil, so it should be fine. And I made this extra little piece. This goes on the back, and when you screw all of this together, basically that runs through there. This gets clamped down by the end of the cable, so it clamps it in place. I use a little fiber washer on the end to provide some oil sealing, and I filed a little groove on the end there so oil can get in there as well. So the idea being, this has all been machined so that this fits in against the end of the camshaft. There's a little tiny bit of movement there, but not much. So there should be enough there for oil to get around everything, but not find its way up the cable, I'm hoping. So that all fits quite nicely on the end of the engine. I have turned the engine over by hand just to check that the drive works, and it does, so that should be fine. There's not a lot of force on those, so hopefully that'll be all right. These are stainless steel studs to hold the housing to the pump, and the pump, I've been working on the drive dog. So what we have here, this is the pump, and you can sort of see inside there is this rectangular driving dog. So I machined up a little piece. It took me 2 goes actually. I'll explain why in a second. The original drive from the Magneto, so as it normally works, there's the little tapered piece, and then it's all one piece. I've cut the taper off the end, and this goes to the gear, which is this, and the gear is what meshes with the gear on the camshaft. So because I wasn't easily able to make this taper, and I could probably make the taper, I just couldn't make the thing for the key, I modified the piece I had. You can buy these new from the Riley spares. I just cut up the one I had. And what I did is cut that end off, that's it there, and then I machined up this separate outside piece, and what I've done is made that a nice tight press fit. And the reason I did that is because of how I have to set all of this up. So the idea is I'll get this in the correct position. I may need to take it apart and reposition it. And the reason for that is when you assemble the Magneto onto the engine, you have to get this drive gear to engage with the cam gear, and this is quite a coarse engagement with those teeth. So you need to make sure that when it engages, you've still got enough movement in these slots to rotate the body of the Magneto so that the timing is correct. And this is what, 13 teeth. So that gives about, each tooth will give you about 27 degrees, something like that, off angle. So you need to kind of get it all to line up. Because this is keyed on the shaft, and this dog is in a particular position on this will have a key on it as well, I imagine. It may take me a little bit of messing around to get this to work correctly. This long drive dog originally had this big long nut, so this is what actually helps hold it on. So you'd put all that together and then you'd tighten this up. So I also had to come up with a way of doing that. So I machined up a special nut that fits down in there, and you can just get a box spanner onto it to tighten it up. And that's what will hold this this drive dog onto the Magneto, and then this is a nice fit in there basically, and that'll provide the drive to the water pump. That's the idea anyway, or rather that provides the drive to the Magneto. The water pump's driven off this shaft, which is at the bottom. It doesn't spin freely. It turns nicely. It feels good. But then I was remembering, well, it's driven off the camshaft anyway, which has a ton of force on it because of all the cam springs, the valve springs. So that should be fine, even though it's not sloppy. It should rotate fine. So the next thing I have to do is check my alignment. And I remember this always takes me a little while to get my head around, because the Magneto also has this adjustment, and I always forget which way round is advance and which way round is retard. I think I can remember now. So I need to get this all set up on the engine to make sure when it's in the correct position, I'm going to have enough adjustment. I won't run out of adjustment for the timing on the Magneto. At least I think that's what I need to do. So in order to do that, you have to get the engine's currently at top dead center with number 1 piston. So number 1 at the front. Being a Riley engine, there's no easy way to turn this over, so I have my starting handle at this end. You turn it over through the dynamo, and it's very hard to see the timing marks, so I've got a mirror, and that's how I was able to make sure I was at top dead center. I'd already previously marked where that is on the flywheel, and you can tell you're on the right cycle by checking the valve clearances. So there's clearance on both those valves, which means both number 1 cylinder valves are closed, so it's on the compression stroke. So what I need to do now is temporarily bolt everything together on that water pump. When you fit the Magneto with the normal drive, you're dropping it down. So the Magneto drops down onto the housing and the gear engages. On this one, it's a bit different because you're coming in from the side. So it may be a little bit fiddlier to get that set up, but we will see. I should add, one of the reasons I didn't end up using this was because when I machined the inside, I overshot the dimension, so it was a loose fit on that other little piece, which meant I had no way of assembling it to be able to then adjust it if I need to adjust the fit. What I'm actually going to do once I get this in the right position is I will probably TIG braze these two together so they can't move. The other reason, I never film all that machining stuff, mainly because I'm not a machinist, and for example, making the new one of these this morning took about 2 hours because I'm not very fast, and trying to film all that at the same time it would just take forever. The other reason is, of course, I only have a small lathe, so you're taking lots and lots and lots of fine cuts, so it takes a long time, and it's just boring. The other thing I should mention is my new tool holder. So this is one of the diamond shaped tool holders. So it takes a little piece of tool steel in there, but you only have to grind one angle on it. It actually comes with a little jig that you can use to help grind the right angle, but this works really well. I'm really impressed with it so far. It means you can get nice tight shoulders on things. It's really easy to set the height. It's really easy to regrind it, and it seems to work perfectly on steel and brass. It just seems very, very nice. Though it's from a company called, I've got this sticker here, Eccentric Engineering in Australia. The good thing about coming from Australia meant it wasn't ridiculously expensive like stuff from the UK or the US, and it arrived really quickly. But yeah, that's made doing this, that was quite fun using that. So I'm going to set this up. I have to bolt this onto here. I think because this drive isn't symmetrical, if you look at where the tooth is on one side compared to the other, so I've got adjustment there that I can play with. I may be overthinking this. It may not matter what the position is as long as it's close enough, but I kind of want to get it correct. I don't really want my Magneto having to be sitting at a weird angle just to get it within the right timing range. I want to try and get it as straight as possible. Okay, I'm not sure if I've been overthinking this or not, but I actually managed to get it pretty much in the right position first try. So that's fully retarded there, and the points are just sort of opening, and that's at top dead center. So the only problem I've noticed is I can rotate it one way but not the other, because it seems like this is hitting. So that's actually where there's some stuff cast, like the BTH logo is cast onto the housing of the Magneto there, and that's actually hitting the top of the timing cover. It's very close. As far as I know, there's not meant to be any sort of gasket or anything inside there, so I think what I'm going to have to do is just relieve that just a little bit, either on the timing cover or on the Magneto housing. I think probably on the Magneto housing, because there's quite a big raised bit there that I can easily just sand down a little bit. But that seems to be about right. I'll get this fixed up. Because of that, at the moment I can rotate the housing this way, and you can see how this gives you the adjustment with the slots, but it won't go back the other way. So that was the other thing I had to do, similar to the other end of this where the water pump went on. I don't think this has ever been used because it was not quite finished, and I had to just deburr and just very slightly sand the inside of the seated, where this seats into here. There's a machined ring so that this is held concentric, but it can still rotate, and I had to just clean that up, just deburr it a bit before this would fit in. So I'm going to have a look at just sanding just the corner off that so that this all nicely fits, and then have another look at it. I did have a bit more of a play around with the positioning of the gear. I didn't actually end up taking it off. I just turned it around 180 because it's not symmetrical on the teeth, and I definitely do have enough adjustment there, so I'm probably overthinking how critical that positioning is, but there's definitely enough adjustment there that I can get the advanced retard where I need it to be. And I ended up filing a little tiny piece off the timing cover, and filed a little bit off the logo here, and that gives me enough clearance so that this rotates nicely. I TIG brazed these two pieces together. Because I'm not sure what these two different metals are, this may be stainless steel, I'm not sure. Didn't machine the same as the other steel. The other steel is 4041, I always get the numbers the wrong way around, but high tensile steel. But the TIG brazing seems good for joining dissimilar things like that together, and it'll easily be strong enough. I was initially worried if that's a big enough drive dog, but then if you look at the size of the driving dog on the dynamo, where it goes into the front of the crank, it's not much bigger than that, so I'm sure that's more than enough. I was also able to test out my new TIG pedal for the first time. That worked really well. And the other thing I've done recently is I bought new screens, or new plastic shields for my welding helmet, and I also put in a +1 magnifying lens, and that definitely seems to help as well. I'm not quite sure. There's different brands of helmet. This is just a sort of cheap Chinese one, online tools branded, but I think most of these come from the same place in China, so the accessories all seem to fit each other, which is good. So That made things a lot easier, so the welding wasn't too hard at all. So I guess the only thing now is to reassemble everything, and I should be able to try firing it up without putting the housing on. I don't need that. It should be enough to be able to fire the engine without the water pump there, without the radiator on, just enough to see that it actually still runs. This is just to show how that driving dog fits onto the end of the Magneto. You can see when I had my Magneto rebuilt, Paul, the chap who rebuilt it for me, fitted a modern seal into the base of it. So that should hopefully stop any oil, because this is running in the timing cover effectively, so there's lots of oil around. Should stop any oil getting up into the Magneto, which is what ends up killing them eventually. You can maybe see on the end there's the nut that's inside there. The other good thing is it's easy to do that up nice and tight, and I use some blue Loctite on it as well, just to make absolutely sure that won't come off. Even if it did come loose, it can't really go anywhere, but I guess if it did, it would probably end up mangling all the drive in here. So I think the next thing is to bolt the housing onto the timing case. Would have been nice to finish on a high note with the engine running again, but I haven't quite got there yet. Trying to get the timing set is really quite fiddly, and when I was first trying, the engine seemed quite hard to turn over, and it's because when I assembled the water pump, put it on the engine, I thought, oh, I better check that I've actually done that nut up on the impeller properly. So I just tightened that up a bit, and I hadn't done it up. And it was easier to do it while it was in the engine because there's something stopping the shaft from turning. It turns out when I did that, it actually tightened up a bit too much, and there was a bit too much friction. It kind of jammed all of this up. It was making it hard to turn over. So I had to take all of that apart again. I machined a fraction off the back of the impeller, did that up tight off the car and made sure it all spun, and that was fine. So that's all good now. I've put it back together. I've been turning it over with the plugs out just to try and get the timing correct. And that gets a little bit fiddly. You have to make sure none of your plug leads short out, because that stops your spark. This is why they're all kind of sitting there. And yeah, trying to get the gear meshing correct is critical, because it gives such a big jump in step. You have to get it exactly right. And I think I've finally got it right. When it's set to fully retarded like that, in that position, the timing mark is just before top dead center, so slightly retarded. I can then adjust it and give it a little bit of advance, but after about, it's either 5 degrees or 10 degrees. I can't remember what my marks on the flywheel are. I think they must be 10 degrees. It stops sparking, and I'm not sure why. It may just be that it's not spinning fast enough. I don't really know. I mean, it should just work. But that should be enough to get it running again. But I've run out of time, and I've run out of battery. So my battery's gone. It's not completely flat, but it's struggling a bit. I am thinking I may need to get a slightly beefier battery, because even this, when it's fully charged, it does seem to struggle to turn over a cold engine. It's only 430 cold cranking amps. I'm not sure what this would need. But the engine is higher compression than a standard Riley engine, so it is going to be harder to turn over. Turning it over by hand, you can feel the compression quite easily. So that's kind of where I've had to stop. I was also hoping to show the tachometer drive working. So you can see that's the drive attached there. Just move that. I don't want bolts dropping into the engine. So there's my cable. Here's the other end. This works fine. It was a bit bent. I had to straighten the end of it. You don't want that wobbling, but that was easy enough. but it seems like my gauge has gone sticky again. So whatever's wrong inside the gauge, it was all clogged up before. I did get it working, but now it seems to have gone all stiff and clogged up again. So I need to take it apart again and really give it a good clean. May have to try and take the face off. The faces on these are really kind of delicate. You don't want to get anything on them because it tends to ruin the paint. So I was hoping not to have to do that, but maybe I will. So the other good thing about this gauge, I realized, is it'll actually go past 4,000. It'll go all the way back around to the little pin. So it actually goes to 5,000 if you go all the way around. But I think that's kind of where I have to stop for the day. I have to go into town tomorrow, so I won't be able to do anything tomorrow night. So it'll be Tuesday night, and hopefully the battery will be fully charged by then. The one last little job I did was I did clean up the timber just around the back of the seats there, so that's all nice and smooth. The next thing to do will be figure out where all the steel brackets go and figure out where the frame bolts to the chassis. Once I've done that and bolted both halves in, I can actually start making the doors, because I need to make the doors to fit more or less. And that's where we're at with this. I'm going to put a dust cloth over it. I don't want anything falling down into the spark plug holes. But yeah, disappointing I couldn't get it running again, but it's pretty close.